boarding the aircraft, then I will have this transition. If I'm moving from the bus to a vehicle, it will push. And from the aircraft to the vehicle, it will replace. So in the slides you will see another conceptual schema, I will not detail here, that we have used for adaptation. So basically we draw a user interface in the first step, then we apply adaptation operations, and then, as in the example, we can play them.
Dr. Jan, we seem to lost video signal.
Sorry. So in the first step,
1 second, please.
We create a user interface.
Could you stop for a second, please, sir?
Yes, sir.
One second. It's just that we have seemed to lost view of your presentation for some reason. 1 second, please. Could you go back one slide to see if it goes back to where it was?
This one?
Yes, I think the connection is a bit slow, and therefore we having a bit of a pixelation. And just give us 1 second to see if we can restart.
Do you want me to do it again?
No, it's just that we just, from the moment I spoke, we lost a bit of quality in the picture of the presentation, and we're just trying to solve it. Could you close the presentation and open it again where you are right now, so we see if we can get back the image?
I am back to the presentation now.
Yeah.
Do you see it?
It's just that it's pixel. We have it's delayed, so for some reason, if we can perhaps close it and open it again to see if it works. We seem to get back on business now. You can proceed now, sir.
Okay.
Yeah, we're doing great now, sir. Carry on, please. And thank you, and apologies for the inconvenience.
That's okay. So now I would like to illustrate how an animation can be produced for showing adaptation. In the first window, we draw a graphical user interface as in any environment. In the second window, we can perform adaptation operations, and they are recorded in the system. And in the end, these adaptations operations are just played with animation. So we hope that the end user will understand what happened. In the end. So for this we have 5 types of operations. First, we can resize objects, like reduce the size of an object. We can relocate objects, like moving one widget to another position. We can transform widgets, like replacing a list box by a drop-down list. We can transform images, like reducing an animation to a GIF, animated file, or we can decompose a window into smaller parts. So here is an example of those operations for which there is a language behind, like set, display or undisplay, replace. So here is an example on how the adaptation is recorded in the system. The first line says, change this list box into that drop-down list. So when the system processes this instruction, it will automatically generate an animation for this purpose. Second line is we need to contract the window because this object has been reduced, so the size is smaller. Then, as you can see, the validate button is transformed into the go, and the cancel button is transformed into that one. This is done by change box and set. So the whole description of the adaptation is made through this language that is automatically processed. So this is the login window that you have seen. Let me show you now other examples of that. So here is a form that is progressively changed with animation to show what changed in the screen.
Dr. Jean, we have the same problem again with the pixelation. If we can perhaps reopen that one once again.
Okay.
Thank you, there.
So here this window is progressively changed, like instead of having boxes, we have drop-down lists. Instead of radio buttons, we have lists again. So you see the radio button disappearing and being replaced by a drop-down list. Again for this one. And the button is moved here. And then you can contract the window to save space. So if you want, you can go to YouTube and again take your time afterwards to review the videos on your own. Now, animation is perhaps nice, but it is not always appreciated. So here we conducted a user study where we asked people, do you like this animation, yes or no? For this purpose, we asked a series of questions to 28 people and users. These questions are here on the left. And on the right you can see to what extent they appreciate it or not. Green means that they are fine with the question. Yellow means that they are mixed up. They don't know whether it is positive or negative. Orange or red means that they don't like it. So for instance, for the first question, do you like the animation? There is no orange or red. So it means that everyone liked the fact to have an animation. However, for the question 11, for instance, is the animation fast for you? As you can notice here, there are some people that did not appreciate the speed of the animation. They said that at some point it is too slow and they wanted to have the animation accelerate. For the question number 4, is the animation easy to use? People regret that there is a lack of control, like how to speed up, how to reduce the speed, how to go to the next step. This was not so easy to do. So the conclusion was people liked indeed animation, but there is a need of big control on that. A second instantiation is about transition between views. So again, you have here the UML class diagram that is behind that implementation, but I will not explain it here. The problem is the following, is that in any software development method you have different steps. You may have different models with different levels like concepts, relationships, attributes, and during the development life cycle we could have different people like different stakeholders, the end user or marketing people, which are totally different people. Where are we? And what type of detail do you want to convey? For instance, if I show a UML class diagram to an end user, he will not understand anything. However, if I show to this person a user interface, this person will react immediately, saying I like this or I dislike that. However, since we are computer scientists, we usually manipulate specific views, while end user manipulates other views. So we need to switch from one view to another. The consequence is that we need to have both switching. Since end users do not understand UML class diagram, we need to switch all the time. And this is increasing, of course, the load. We need to think all the time about that. And learning is slow. So what we would like to do if we have in general 3 views, the external view, this is for the end user. The conceptual view, this is the view for the computer scientist, like UML diagrams, state charts, activity diagrams, conceptual schemas. And the internal view is the representation of the view for the system. So at any time we need to switch from a conceptual view to an internal view and then produce an external view for the end user. And since the external view works for end user, of course there will be some feedback like this. We'll have a loop. Then we have to go back to conceptual and then again to internal. So this is a long process, it's tedious. For instance, if I'm working here in XWT, I have an external view which is the end user one. I have a conceptual view which is a project hierarchy here. And I have the internal view which is the code. And of course I have to maintain the consistency between the external view, the code view and the project view at any time. And I need to switch from one view to another. Another example of that is Forms VBT. In this environment, you have the final view of the user interface. You have another view in terms of boxes. And you have the code view in terms of LaTeX. So for those of you who are familiar with LaTeX, you can type your LaTeX here. So if you know LaTeX, you can type here, and this is automatically propagated in the external view and then in the final view. Even better, if I take, let's say, if I click on this OK button and I move it on another part, then my code will automatically change, which is easy. So this is why there is a synchronization between this view and that view. A more sophisticated example is Jeff 3D. On the left part you have here a UML class diagram. On the right part you have the structure of the interface. And here on the bottom you have the real interface. And you have a lot of links between. Like here, more and more and more. So in the end, it is hard to follow. So in order to address this problem, we have defined a methodology that defines what is the initial view, the final view, what are the mappings between the different views, what type of transition we can establish between, and what kind of animation. So let me show you now how it works.
Developing the graphical user interface. view consisting of a UML class dot regression from it.
So now, here for instance, I have the XML code of a user interface written in use XML. Do you see this screen? And if I want to switch from this view, the code view, to the real user interface, I just click on one key.
Internal view consisting of the XML description of a user interface to.
And then I have the transition between the code view and the user interface. I can also control the speed of that view thanks to a control key. Pressing the Ctrl plus may speed up, while Ctrl minus will reduce the speed. In this way you can see what part of the code will be transformed to what object in the user interface. Another example is that you can highlight a portion, like here, and say, what does this mean? If you click on that area, the system will animate that part for you to understand what does it mean. Now here I have a more graphical view of a user interface, which is the conceptual view for a car rental application. Here I have the identity of a customer, her address, what are the preferences of the car, what type of car do you like, and additional comments. Again, you can see a transition between those different views. So for this purpose, we have different types of animations, like how to transform text to text, text to position, text to length, or to color, etc. In order to choose the appropriate animation, here is a graphics that recommend you which is the best representation of a variable. So those presentations are ranked according to the level of precision. So for instance, position is the most precise one to express a quantity. Is the second one, and density comes from here. So this means that expressing the order by a density representation is usable. Again, shape is the worst one, so never use shape as a representation for ordinal value. It is unusable. In particular, color is always very good, because usually people can distinguish between 9 different colors just on one screen. So color is good, but it's complex. So this is why we have color here on the 4th and color on the 2nd position for nominal values. So So usually we are very good in distinguishing colors. We can see up to 9 different colors on the same screen. Other representation like angle are not so good, because here you can see that they are not so high for ordinal and nominal values. So of course there is a lot of implementations if we want to consider all these representations. Right now we don't have them all, we have just some of them. So as you have seen in the demo, we have ensured a transition between the conceptual view, which is a hierarchy of objects defining a user interface. Then we went to the corresponding graphical interface, and then we have also a connection with the code. But I didn't illustrate this transition. We don't support it yet for the moment. So for instance, if I'm working on the conceptual view, I may want to go to the external view. Or from the code to the graphical user interface. From some identified part, if I want to understand exactly what does this mean, I can speed up or slow down the process. In the previous experiment, people complained about not controlling the speed. So here we did improve that. Another very interesting related work is called Glimpse from Pierre Dragicevic in France. You have a window with the code view, and it works for HTML, XML, or even LaTeX. And on the right, you can see the rendering of that through animated transition between. So this is a very interesting piece of work. Let me show you how it works. So here, as you can see, you have HTML, and at any time you can switch from HTML to its rendering. Or on Wikipedia, you save the page, and then you can have the look at the rendering. So always code, view, code, view. Instead, with Glimpse, you just press one key and you switch from the code to the view immediately. So instead of always switching between the code and the view, you just have an animation between the two. Here is an example with a user interface. You have HTML coding behind that. And here is the HTML code corresponding to that. So if you want to edit some part, you just select the part that you want to edit, and you are right there in the HTML code. Or here there is a mistake. It's not project project, just click on it and change that in the code.